9.5 trigonometric ratios. We already kind of did an introduction to trigonometric ratios, so we're going to go through the first part a little bit fast. To remember what each trigonometric ratio stands for, sine, cosine, tangent, we can use this tool for remembering it, so, ka, toa. You remember how to spell that. This stands for sine is the opposite side, the side opposite of our reference angle, A. Label that my reference angle. Okay, that's my reference angle, so the side opposite reference angle over the hypotenuse. Cosine is the side adjacent. Adjacent means next to. So the side next to angle A, that is not the hypotenuse. So this would be my adjacent side because this is my hypotenuse. And tangent is the side opposite angle A over the adjacent side. So when we look at those ratios, we can solve a lot of problems, okay, given not very much information, because if you know two angles, the triangles are similar, and these ratios will always be the same for any two similar triangles. So as long as the angle is the same in one triangle, this ratio is always going to be the same. So our first example is compare the sine, cosine, and tangent ratios for angle A in each triangle below. Okay, so sine A is the opposite over hypotenuse. So the opposite side for triangle ABC, the opposite angle A is 5. The hypotenuse is the longest side. That's always across from the right angle, 13. Okay, and if we put that into our calculator, 5 divided by 13 is about 0.3846. 0.3846. And when we write out these as decimals, we go to the 10,000ths place. Okay, 4 decimal places. Now the cosine of A, I'm going to erase these marks so we don't get confused. If I do the cosine of A, the adjacent side is the side that's not the hypotenuse. That's 12 over the hypotenuse 13. It's going to be pretty close to 1, but it's not quite. 12 divided by 13 is 0.9231. We'll round it up. 0.9231. And the tangent, the hypotenuse is 13. The tangent, opposite over adjacent, we already know the opposite side is 5. And our adjacent side is 12. So 5/12 is 0.416. Okay, so now that was for this triangle. Now if we do the same thing for this triangle, the sine of this triangle, we don't know, it's a different angle A, but we'll see what the sine of that is. It's opposite over hypotenuse. Opposite side over the hypotenuse. Hypotenuse is my longest side, always across from the right angle. So 2.5 over 6.5. With the decimals, I like to double it. So that would be the same thing as 5 over 13. Notice it's going to be the same. So these triangles are actually similar by side, side, side. As we'll see here as we start doing more of these. Cosine, adjacent over hypotenuse, so ka, right? Think about if you don't have this written out, you'll want to remember so, ka, toa. right? So my adjacent over hypotenuse. Adjacent is next to the side over my hypotenuse 6.5. If we double that, that's 12 over 13. That's going to be the same. And you already know this is going to be the same. The tangent is opposite over adjacent, 2.5 over 6. Opposite angle A over the adjacent. And that's going to be the same. Double it, you get 5 over 12. Find the sine, cosine, and tangent of the indicated angle. So what is the sine of D in this problem? Sine of D, if you need to, write out your SOHCAHTOA. Make sure you know how to spell those. So sine is opposite over hypotenuse. The opposite side to angle D is 14. Right, so I always start at this angle. Now if they ask me about angle E, the opposite side to angle E is 48. So make sure you pay attention to your reference angle. 14 over the hypotenuse, 50. Okay, the cosine of D is adjacent over the hypotenuse. So this would be the 48 over 50. And the tangent of D is opposite over adjacent, 14 over 48. Okay, the opposite side to angle D over the adjacent side, that's tangent. So it really comes down to you knowing what those ratios stand for. Now, we're going to quick do E because it's kind of interesting. The sine of angle E, from angle E, we're going opposite over hypotenuse. We get 48 over 50. The cosine of E, cosine is adjacent, the non-hypotenuse side, the side next to it that's not the hypotenuse, so 14 over the hypotenuse, 50. And tangent is opposite over hypotenuse. So notice 48 over 14. This is the only, tangent's the only ratio that can be greater than 1. All these ones are always going to be less than 1, sine and cosine, for a right triangle. Now hopefully you recognize the connection that the sine of D and the cosine of E are both the same. The cosine of D and the sine of E are the same, and the tangents are reciprocals of each other. Find the exact value of the sine, cosine, and tangent of a 60-degree angle. So if you have a 60-degree angle, this is a 60-degree angle, here's a 30-degree angle, this is a special right triangle, we should be able to find the side lengths. Now, does it matter what the side lengths are? No, you just have to pick one and then figure out the other side lengths from that. I picked this as one because it's the easiest. So pick one side length in this case because we're just looking for the sine. It's a ratio. All of the triangles are going to be similar that have 30, 60, 90 ratio, and the ratios are all going to be the same. So I'm going to pick this side, and then I'm going to figure out the other sides. Okay, figure out the other side lengths. So if this is a 1, remember 30, 60, 90 triangles, half an equilateral triangle. So if this is 1, the hypotenuse is 2, and it's nice to just remember that that's the square root of 3. So if we're looking for the sine of 60, the sine is opposite over hypotenuse. So the square root of 3 over 2 would be the exact answer for what the sine of 60 degrees is. Okay, the cosine of 60 degrees is adjacent over hypotenuse, the adjacent side over the hypotenuse, 1/2, right? The side that's not the hot hypotenuse, but next to it. And lastly, the tangent. Tangent is opposite. So here's my reference angle, the opposite side, square root of 3, over the adjacent side, which is 1. Now, we found exact answers using our special right triangles and jumping all over the place here. Sorry. In this problem, we found the exact answer what the tangent of 60 equals. Tangent of 60 equals the square root of 3. You can use your calculator to figure out other things, like what is the sine of 82 degrees? Now, all calculators are different. I'm going to just show you how the one on the computer works. It's a little bit different. Sometimes you can just type it right in, just like this. Just type in sine of 82 and hit enter. But on this kind of calculator, it's very basic. I'm actually going to have to hit 82 first, and then I'm going to hit sine. And then it does the calculation. I get 0.9903. 0.9903. I rounded that one up. Okay. If I want to do cosine of 82, type in 82 first on this, and cosine. So cosine 82 is 1392. 1392. Now, if you don't have a calculator to do this, in the back of your book on page 845, there is a table with this all listed out. Okay, so if you don't have a calculator, you can use the table, but it's just a lot more work. So somebody took the time to, measure this all out and figure all these ratios out so that we can solve more advanced problems. And lastly, the tangent of 82 degrees. Remember, depending on your calculator, you type it in differently. Most calculators, you just type it in just how it looked. I don't think that's the right button. I wonder if I hit the wrong one. I'll try it again just to make sure. 82 tangent, yep, just is 7.1154. Okay, so remember, tangent's the only one that can be bigger than 1. Now, one thing you want to be careful of is to make sure your calculator is in degrees. Okay, there's other ways of measuring angles, radians and grade. So let's make sure your calculator's in degrees. A lot of calculators at the top will say DEG. That's good. If it says RAD, that's bad for right now. Okay, as you get into higher level math, you like radians better. They just work a lot nicer for a lot of problems. Let's see here how many problems we got left. Don't want to go too long here. You're measuring the height of a building and you're standing 100 feet away. From the base of the building, you measure the angle of elevation from a point on the ground to the top of the building to be 48 degrees. You know this is 48 degrees. Estimate the height of the building. With this much information, we can solve for x. This is a typical MCA question that you need to be very good at solving. So to do this, you got to look at what sides are we given. From this reference angle, this is my opposite side, and this is my adjacent side. So what ratio compares opposite and adjacent? And that is your tangent ratio. The tangent is opposite over adjacent. So I know the tangent of 48 degrees has to equal, in this case, we're looking for x, and we know the adjacent side. So now I can solve for x to get x by itself. Okay, I can put this over 1 so that I can cross multiply and divide, or basically 100 times the tangent of 48, and that's going to tell me what x is. So I go to my calculator, figure it out. The tangent, tangent of 48 times 100, and that's going to tell me 111.06. And this was measured in feet, so this is also in feet. That's the approximate height of the building. You need to skip this example. I know this is getting long, but it's kind of a tough section. So it helps to draw pictures. A driveway rises 12 feet. It goes up 12 feet over a distance d. At an angle of 3.5 degrees. Estimate the length of the driveway. So once again, you look at the sides. We don't know the hypotenuse. We're looking for the length of the driveway. So that's the hypotenuse. So in order to find that, we're going to set up a ratio, and I want to find this. That's my hypotenuse, and I know my opposite side. So what compares opposite and hypotenuse? And I can do this pretty fast, but it's the sine. The sine of 3.5 degrees is going to equal my opposite over hypotenuse. Solve this by putting it over 1. I cross multiply and divide by the sine of 3.5. That's going to tell me my answer. 12 divided by 3.5 sine. That's what I'm looking for. So I'm confident when I hit equals 196.56. And that kind of makes sense. That's a very narrow, so you're going to get a long driveway that way. There's your homework assignment. One of the things we're going to be calculating the ratios for angle A that come first in the alphabet. You don't need to do all the ratios. That gets to be pretty long. So if there's, don't do the right angle if that's the first letter, but just do the first letter in the alphabet. I'll explain that in class. Have a good night.